Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of cloud computing. We'll dive into key concepts like Introduction to SOAP, WSDL and UDDI, RESTful services, definition, characteristics, components. Let's get started. Slide 1. Introduction to SOAP. SOAP, or Simple Object Access Protocol, is a messaging protocol used for exchanging structured information in distributed systems. Unlike other approaches, SOAP is strictly XML-based, which means all its messages are encoded in XML, providing a consistent and structured format. One of SOAP's strengths is its protocol independence. It works not only over HTTP but also SMTP, TCP, and others, making it versatile for different applications. SOAP is platform neutral, meaning it's not tied to a specific language or OS. This ensures that a Java-based client can interact seamlessly with a net-based server, for example. SOAP messages are highly standardized. Every request and response must adhere to strict XML schemas. This strictness ensures reliable communication, especially in scenarios requiring guaranteed delivery, such as financial or healthcare systems. SOAP also has built-in security features like WS Security, which allows for encryption and authentication. For instance, a banking system uses SOAP to securely transfer transaction details between servers. Its structured and secure nature makes it perfect for enterprise-level applications. Slide 2. WSDL, Web Services Description Language. WSDL, or Web Services Description Language, is the blueprint of a web service. It's an XML-based language that describes what a service does, how to interact with it, and where it's located. Think of WSDL as a contract between a service provider and its consumers. The WSDL structure includes service endpoints, operations, and message formats. For instance, if you are using a weather forecast service, the WSDL file will specify all the operations you can perform, such as checking the temperature or humidity, and define the data you need to send and receive. Its machine-readable nature allows developers to integrate services quickly without diving into the code. Additionally, WSDL ensures platform independence and interoperability. For example, you can use WSDL to describe a SOAP-based weather API, enabling clients in different programming languages to consume the service seamlessly. Slide 3. UDDI, Universal Description, Discovery, and Integration. UDDI acts like a directory for web services. It helps businesses and developers discover and publish web services. Imagine you are a travel agency looking for airline reservation APIs. UDDI allows you to search for these services based on specific criteria. UDDI's registries are categorized as private, public, or shared. Public registries are open to everyone, while private ones are limited to specific organizations. The UDDI structure includes service descriptions, provider details, and categorizations, making it easier to locate the right service. By combining UDDI with WSDL and SOAP, you can create a robust service discovery and integration environment. For instance, a business can use UDDI to locate potential suppliers, examine their service offerings using WSDL, and interact with them using SOAP. Slide 4. RESTful Services Definition. REST, or Representational State Transfer, is an architectural style for building networked applications. Unlike SOAP, REST isn't a strict protocol but rather a set of guidelines for designing systems. One defining feature of REST is its statelessness. Every client-server interaction is independent, which simplifies scaling and ensures that servers don't need to store session data. REST treats every functionality as a resource, such as a user profile or a product list. These resources are accessed using unique URIs. REST relies on HTTP methods like GET, POST, PUT, and DELETE to interact with resources. It supports multiple data formats, including JSON and XML, which makes it highly versatile. A common example is a RESTful API fetching weather data in JSON format for a mobile app. REST's lightweight and flexible design makes it ideal for modern web and mobile applications. Slide 5. Characteristics of RESTful services. RESTful services have several key characteristics. The first is statelessness, meaning each request from a client to a server is independent. This ensures scalability as servers don't need to manage sessions. REST follows a client-server model, separating user interface concerns from back-end logic. This allows developers to work on different parts independently. Responses in RESTful services are cacheable, improving performance by reducing redundant processing. REST also has a uniform interface, meaning the same set of operations, like GET or POST, can be applied across all resources. Its layered system architecture allows intermediaries, like load balancers, to enhance scalability and security. Finally, REST supports hypermedia, meaning responses can include links to related resources. For example, a response for a user profile might include a link to that user's order history. Slide 6. Components of RESTful services. RESTful services are built around several core components. The primary element is a resource, which can be any object or data, like a user, product, or order, accessed via a unique query. HTTP verbs like GET, POST, PUT, and DELETE are used to perform actions on these resources. For example, a GET request retrieves data, while a POST request creates new data. URIs, or Uniform Resource Identifiers, serve as the addresses for these resources. Data is exchanged in formats like JSON, XML, or plain text. REST uses stateless communication, meaning no session data is stored on the server, enhancing scalability. Hypermedia links in responses help clients navigate between resources. Lastly, headers in requests and responses provide additional metadata, such as content type or authentication details. This component-based design ensures RESTful services are simple, scalable, and efficient. Slide 7. SOAP versus REST key differences. SOAP and REST differ in many ways, each suited for specific use cases. SOAP is a strict protocol with predefined standards, while REST is a flexible architectural style. SOAP messages are always in XML, making them more rigid but highly structured. In contrast, REST supports various data formats like JSON and XML, offering flexibility. SOAP can be stateful or stateless, while REST is strictly stateless, enhancing scalability. SOAP's ability to work over multiple protocols like HTTP and SMTP makes it versatile, but REST's focus on HTTP simplifies its use. SOAP is often slower due to its overhead but excels in reliability and security. REST is faster and lightweight, ideal for web and mobile applications. For instance, a financial institution might use SOAP for secure transactions, while a social media app might prefer REST for its speed and simplicity. Slide 8. Advantages of SOAP. SOAP offers several advantages, starting with its robust security. Features like WS security ensure encrypted and authenticated communication. SOAP guarantees reliable messaging with built-in error handling, making it ideal for critical systems. Its protocol flexibility allows it to work over HTTP, SMTP, and more, providing versatility. The standardized XML format ensures consistency across different platforms. Additionally, SOAP supports complex operations like distributed transactions, which are common in enterprise environments. For example, a payment gateway using SOAP ensures secure and reliable transaction processing. These features make SOAP a strong choice for enterprise-level systems requiring high reliability and security. Slide 9. Advantages of REST. REST's simplicity is one of its biggest strengths. It's easy to implement, making it accessible to developers of all levels. Its lightweight nature ensures minimal overhead, improving performance. REST's flexibility in supporting multiple data formats like JSON and XML makes it versatile for modern applications. Statelessness enhances scalability by eliminating server-side session management. REST's caching capabilities further improve performance by storing frequently accessed data. Its widespread adoption ensures compatibility with most modern platforms and tools. For example, an e-commerce site might use RESTful APIs to fetch product details quickly, improving user experience. Slide 10. UDDI and REST integration. UDDI and REST can complement each other. UDDI serves as a discovery mechanism for locating RESTful APIs. This simplifies the process of integrating RESTful services into existing systems. Using UDDI, organizations can find and publish RESTful services in a structured way, bridging the gap between modern and legacy systems. For example, a logistics company might use UDDI to integrate new RESTful APIs into its existing SOAP-based system, ensuring interoperability and flexibility. This hybrid approach leverages the strengths of both technologies, providing a seamless and scalable integration experience.